In the last video, we broke down a 1-star fire hazard review of the JRready ST9019 harness and compared its rating with what an air ride system typically draws. Today, no arguments, just testing. We'll run two current levels, 8 amps and 13 amps, to see how the ST9019 behaves within its rated range. Here is the equipment used today: a DC power supply, a load, an emitter, a thermometer, and then a brand new ST9019 DT wiring harness. The plan for the two test runs is: first, 8-8 simulate low load operation. Second, full rated current aeration. Quick note, the original ST9019 wire length is a bit short for our bench layout. So on the end opposite the Deutsch connector, we extended it using the same 14 ARG wire. The extra length adds very little resistance, so it doesn't affect our conclusions about how the harness and connector heat up. You can safely rely on the test results we're about to show. Now, the wiring harness has been connected and the current has been set to 8 amps. We'll let it run continuously for 30 minutes, then measure the temperature again. After 30 minutes, the surface temperature of the wiring harness is approximately 34.9 degrees Celsius. It feels warm to the touch, which is within the normal operating temperature range. Under this kind of low load, the temperature rise of the ST9019 is low and it easily meets the requirement. We'll wait for it to return to its initial state, then measure its temperature. Next, we'll increase the current to 13 amps, which is the rated current this wiring harness is designed for. We'll let it run for another 30 minutes as well and observe the temperature change. Now, the maximum temperature measured is approximately 51.4 degrees Celsius. It's higher than before, but still within the normal operating temperature range. And this shows that with correct wiring and normal heat dissipation, the ST9019 can operate stably within its rated current. From these two tests, there are two key takeaways. First, at 8 amps, the ST9019 only warms up moderately. At 13 amps near its rating, it gets noticeably hotter, but still within the normal range. Second, what usually turns a harness into a real fire hazard is not the rated current itself, but overloading it, undersized wire, poor ventilation fuzzy, and bad crimps, all stacked together. There's one more thing we really have to talk about, besides current and wire gauge. Crimp quality is something many people overlook, but it's absolutely critical. We'll dedicate the next video to a hands-on crimping demo and pull test to show you exactly what a proper, acceptable crimp looks like. If you'd like to see other harnesses or connectors tested like this, tell us in the comments. Please like and subscribe, and we'll see you in the next video.